Section 6.2 is on using substitution and elimination to solve systems. The first technique we're going to look at is the substitution method. We start by solving one of the equations for either x or y, doesn't matter which, and then we're going to plug that value for x or y into the other equation to solve for one of the variables. So in the first example, notice that we already have y solved for. Y is equal to 4x plus 7, so we're going to plug that in for y in the other equation. So the first equation becomes negative 3x plus 2 times, replace that y with 4x plus 7, equals 9. We're going to use a distributive property. We're just going to solve this thing for x here. So 3x plus 2 times 4 is 8x, plus 14 equals 9. Combine like terms, we have 5x plus 14 equals 9. And subtracting 14 from each side gives us 5x equals negative 5. So if you divide both sides by 5, you're going to get x equals negative 1. Alright, now take that value for x, plug it into the equation to find y. I'm given y equals 4 times negative 1 plus 7. Y equals negative 4 plus 7, or 3. So now I know both values for x and for y. So I know the solution to this system. The solution to this system is the ordered pair where x is negative 1 and y is 3. Let's look at another example. In part B, we don't have a system where x or y is solved for, so we're going to solve for one of the variables. It's usually best to check out all of your variables and find the one with the smallest coefficient. So in that case, it's the y in the second equation because the coefficient is 1. So we're going to take this equation and solve for that y. So we're going to subtract 2x from both sides. It'll give us y equals negative 2x plus 5. Now that y is solved for, we're going to take what y is equal to and plug it in for y in the other equation. So the top equation becomes 2 times negative 2x plus 5 equals 8 minus 4x, and we're going to solve this for x. So distribute, it gives us negative 4x plus 10 equals 8 minus 4x. Now to solve for x, we would add 4x to both sides. And the x is added to 0 here, so we're going to have 10 equals 8. Negative 4x plus 4x is 0. So we've seen this happen before. When you get a statement like 10 equals 8 and there are no x's anywhere to solve for, this is going to mean the no solution case. So what really happened here? No solution happens if these two lines happen to be parallel lines. So that's what's going on here. No solution. Let's go to the next page. Alright, we're going to use substitution again. So let's start by finding a good variable to solve for. My coefficients are 2, 1, 5, and 3. So the y in the top equation is a good one to solve for. So I'm going to subtract 2x from both sides. It'll give me y equals negative 2x plus 10. And when I plug that into the second equation for y, we're going to get 5x plus 3 times negative 2x plus 10 equals 3. So that gives us 5x minus 6x plus 30 equals 3. Or, combine like terms, negative x plus 30 equals 3. So, if you subtract 30 from both sides, you'll get negative x equals negative 27. And then divide by negative 1. You got your value of x. X is 27. Okay. Now take that value of x, plug it into the equation, and get the value of y. So y is equal to negative 2 times 27 plus 10. So y is equal to negative 54 plus 10, or negative 44. So our ordered pair solution here is 27, negative 44. You can always check that this is true by plugging both x and y into one of your equations. So let's check that when you take 5 times 27 and add it to 3 times negative 44, you get 3. So 5 times 27 plus 3 times negative 44 is 3. So our equation checks out in the second equation. You can check it in both equations, and it should be true in both equations. Alright, let's look at the next example. Part D. Alright, let's find a variable to solve for. So my coefficients are negative 1, 3, 2, and 6. The coefficient negative one's going to be the easiest one to solve for. Their smallest coefficient, the one closest to 1. Alright, so in this equation, I'm going to start by subtracting the 3y from both sides. Gives me negative x equals negative 3y plus 4. And then divide everything by negative 1 to get x by itself. So x equals 2 negatives right there will make positive 3y, and a negative and a positive will make negative 4. We're going to take what x is equal to and plug it into the other equation for x and solve. Now we have 2 times 3y minus 4 minus 6y equals negative 8. Let's distribute. That's 6y minus 8 minus 6y equals negative 8. And if you combine like terms, 6y minus 6y is 0y, so no y's there. And you have negative 8 equals negative 8. Now, unlike the example on the last page, this is true, so it's not no solution. No solutions when I get a false statement. This is going to be infinitely many solutions, or all points on the line. You can use either of your equations to represent this. So all points on the line, 2x minus 6y equals negative 8. Either of the lines is an okay way to represent this. For our note right here, we'll remind ourselves that something such as 2 equals 5, when they're not true, is the no solution case. And something like 4 equals 4, where is true, is the all points on the line case. Let's look at the next page. Alright, let's check out the elimination method. The elimination method is another way of solving the same type of equation. Sometimes there are going to be equations where no variable is convenient to solve for, so we're going to want another method. In the elimination method, I want to eliminate a variable by adding the two equations together and having something add to 0. If I look at these two equations, when I add them, I would add to 7x or to negative 1y, something to eliminate. So we're not quite ready to add them yet. First, I want to multiply by the number required to create the least common multiple in one equation and the opposite in the other. So let's check out for x's. If I want to eliminate x, I could make these both 12s by multiplying the top equation by 4 and the bottom equation by 3. So the least common multiple for x is 12. The least common multiple for y is 2. And usually I want to pick the one that has the smaller common multiple and get rid of that value. It's going to make my number smaller and easier to work with without the problem. Okay. So, to get a 2 in the top equation, I don't need to multiply by anything. I already have one. And to get a 2 in the bottom equation, I need to multiply by 2. I do want one of them to be a positive 2 and one of them to be a negative 2, otherwise they wouldn't add to 0. Okay, so let's multiply our equations out. The top equation stays 3x minus 2y equals 8. And the bottom equation becomes 8x plus 2y equals 14. Add those together. 11x, no y, equals 8 plus 14 is 22. Divide both sides by 11, we have our x value. Alright, now that we have the x value, we're going to use either of our equations, doesn't matter which one you want, to solve for y. So let's use the top equation. So we're going to have 3, our x is 2, minus 2y equals 8. So that gives us 6 minus 2y equals 8. And if you subtract 6 from both sides, negative 2y equals 2, or once you divide by negative 2, y equals negative 1. So the solution to this system is the ordered pair 2, comma, negative 1. Alright, let's check out another example. In part B, if you use the x's, limit the x's, the least common multiple is 6. If you eliminate the y's, the least common multiple is 20. So we're going to go with x since it has the smallest common multiple. So I need to multiply the top equation by, if I want to get 6, I want to multiply everything by 2. And if I want to get 6, I need to multiply everything by 3. Now that would give me a positive 6 in both of them, so we're going to use a negative 3 here to get a positive 6 and a negative 6 so that they add to 0. Okay, top equation is going to become 6x plus 8y equals 18. Make sure every single piece gets multiplied by 2. And the bottom equation is going to become negative 6x minus 15y equals negative 39. Make sure every single piece gets multiplied by negative 3. Add up your two equations. 6 plus negative 6 is 0. 8 plus negative 15y is negative 17y. 18 plus negative 39 is negative 21. Divide by negative 7, we get y equals 3. To find the value for x, we're going to take our y equals 3, plug it into one of the equations. So that's 2x plus 5 times 3 equals 13. We have 2x plus 15 equals 13. Subtracting 15 from both sides will give us 2x equals negative 2. Divide by 2, x is negative 1. So the solution to this system is the ordered pair negative 1, comma, 3. Alright, next page. We're going to use elimination to solve this system. Again, let's check out both variables. If I get rid of my x's, I could make those both 12s. If I get rid of my y's, I could make them both 15s. So we're going to go with our 12s. It's just a smaller number, keeps things simpler. I would multiply by 3 to get a 12 in the first equation, and by 2 to get a 12 in the second equation. That would give us positive 12, so we need to make sure that one of those is negative to give us one positive 12 and one negative 12. The top equation becomes 3 times 4 is 12x, minus 3 times 3 is 9y, equals 3 times 10 is 30. Second equation, negative 2 times 6 is negative 12x, negative 2 times negative 5 is positive 10y, and negative 2 times 8 is negative 16. If I add these equations up, the x's eliminate, they add to 0x, the y's add to 1y, and 30 minus 16 is 14. So we have our y value. Continuing on, if we have our y value, we're going to plug that into one of the equations, doesn't matter which one, to find the x value. Let's just use the top one. So 4x minus 3 times 14 equals 10. So 4x minus 42 equals 10. Add your 42 to both sides. We have 4x equals 52, and divide both sides by 4. X is equal to 13. So the solution to this system is the ordered pair 13, 14. Look for your least common multiple of your x's. 5 and 10 both go into 10, and 2 and 4 both go into 4. So we're going to get rid of the y's. To make the y in the top equation of 4, we need to multiply by 2. And to make the second equation have a 4y, we don't need to multiply anything. You can multiply by 1, but it doesn't change that equation. So we're going to have a top equation with a negative 4, bottom equation with a positive 4. That's perfect. That'll give us 10x minus 4y equals 24. Very important not to forget to multiply every single piece by 2. And negative 10x plus 4y equals 7. Negative 10x minus 10x is 0x. Negative 4y plus 4y is 0y. So you have nothing on the left-hand side. equals, and then 24 plus 7 is 31. This is not a true statement, so the answer is no solution. For our note here, don't forget that you don't have to have anything on this side. It's completely okay to get 0 if your x's and y's both eliminate. The question of whether or not it's going to be true is whether that 0 is equal to 0 or 31 or 7 or another number. Okay? So if our 0 is equal to a number like 2, it's no solution. But if we had 0 equals 0, then all points on the line would be the solution. In example 3, we can use either substitution or elimination. At the hint says, to first clear fractions by multiplying each equation by its least common denominator. So in the first equation, let's multiply everything by 4. There's no need to work with fractions. We might as well get rid of them since we have an equation here. 4 times 1/2 is 2x. 4 times 3/4 minus 3y. And 4 times -4 equals -16. The common denominator in the second equation is 3. Let's multiply everything by 3. 3 times 2/3 is 2x. 3 times 1/3 is 1y. And 3 times -4 is -12. Now let's decide if we want to use substitution or elimination. I'm going to go ahead and use elimination because I already see that I have 2x and 2x. If I multiply everything by a -1, negative, positive, positive, I'm going to be able to add these two equations together and get rid of the x's. So that'll leave us with -3y plus y is -2y. And -16 plus 12 is -4. Divide both sides by -2. Gives us a y value of 2. Now when I go back and plug y equals 2, instead of using one of the equations that has fractions, I can use any equation that has both x and y. So I'm going to go ahead and use this equation right here. Alright, so now I have -2x plus a y value of 2 equals 12. Subtract 2 from both sides. -2x equals 10. And divide both sides by -2. We get x equals -5. So the solution here is the ordered pair -5, 2. Example 4. This equation has decimals instead of fractions. And the way it's set up, I know that y is equal to -4.25x minus 2.19, and y is equal to 3.65x plus 9.38. So when I solve these, substitution is the most convenient method. I can plug -4.25x minus 2.19 in for y. So now it's equal to 3.65x plus 9.38. This is the most common method to use if I'm going to solve a system of two equations I got from regression, for example. If I'm going to have decimals like this, I can use substitution to solve them. Let's start by adding 4.25x to both sides. That'll give us -2.19 equals 7.9x plus 9.38. Now subtract 9.38 from both sides. -11.57 equals 7.9x. I'm going to grab my calculator to divide both sides by 7.9. We round that to the nearest hundredth, we'll be at -1.46 for our solution. And last but not least, we need to find our y value. So let's take and plug the x value into either equation for y. I'm going to start with the first equation there. So y equals -4.25 times -1.46 minus 2.19. I find that y is equal to 4.02 in the hundredths place. So the solution to this system is the ordered pair -1.46, comma 4.02. Now normally it doesn't matter at all which equation you use to plug the x value back in. You'll get the exact same value for y. But since this value for x was rounded, I might get something similar but slightly different. So let's check this in the other equation. The x value is negative 1.46, and here's our equation for y. So if I take 3.65 times negative 1.46 and add 9.38, you see that you get something very similar but slightly different. This is 4.05 instead of 4.02. And again, that's because we had to round the value for x right here. So either of these answers would be acceptable depending on which equation you use when you solved for y. Last, we have a summary here. 3 cases for systems. The first case is the intersecting case. When you solve this algebraically, you're going to get a numeric value for x and y. So you get something like x equals 2, y equals 7, for example. So you'll have the ordered pair 2, 7. And what this looks like would be 2 lines that cross at their common solution. The next case is parallel or inconsistent. A parallel or inconsistent system is a set of 2 lines that don't cross, so the answer is no solution. And you know that you have no solution if your answer turns out to be like 0 equals 2 or 2 equals 7. It's something that is not true. Will give us no solution and will indicate that the lines are parallel or the system is inconsistent. The last case is an identity or a dependent system. If you were to draw a dependent system, you would only see one line because both lines are exactly the same. The answer is going to be all points on the line. And what you would see if you've solved this was something like 0 equals 0 or negative 5 equals negative 5. A true statement as opposed to the false statement you see in the parallel or inconsistent case. Alright, and that's it for this section.